Okay, we into fun stuff.
When you say fun, it's never good.
Oh my God.
You be hating to. Okay, so we have now oxidation, reduction, reactions. Our redox. Redox reaction simply, these two things must always come together. If something is oxidized, something was reduced. Okay? Oxidation occurs when an atom or an ion loses electrons. Reduction, who? Don't tell me. Yeah, you donate to somebody else. Yeah. Right? Reduction occurs when an atom or an ion gains electrons. Right? Chemical reaction. You will have non-redox and redox reaction. In order to figure out which is which, you must do the math. Don't be rolling your eyes at my math. Okay? So now, you have in your non-redox, you can have combination, double displacement, or decomposition. In your redox, you can have combination, single displacement, or decomposition. There is no way to sit here and classify a particular type of reaction as redox and another particular type of reaction as only non-redox.
Is that in the slides? That's not over there, right?
This?
What you just said, that's not in this one.
I don't know what you're talking about.
You said non-redox is combination, single.
No. Listen to what I'm saying. Examples of them
Yeah, that's
is here.
what they.
However, you will not know by knowing the types of reactions. The only way to tell if a reaction is redox or non-redox is to do my math. You must do my math.
So you would recommend writing that down?
No, that's not. Okay? I have my 7 rules for my redox reactions. And we're going to see them, we're going to learn them, we're going to love them. See how she's trying to get at me? It's not a petri dish. Okay? So, the concept of oxidation numbers. Oxidation numbers, this is how we're going to tell if a reaction is redox or non-redox. By our oxidation numbers, or it's called oxidation states. Okay? So here, for example, okay, ways of figuring out if oxidation occurred or if reduction occurred. Oxidation has occurred if you have combined with oxygen. If you lose hydrogen, if you lose electrons, or if you increase your oxidation number.
Wait, repeat that?
If you combine with oxygen, you have undergone oxidation. If you lose hydrogen, if you lose electrons, if you increase your oxidation number. Yes?
So then I could classify an oxidation occurring from just like the bronze status.
You can look at a chemical equation and be able to see just from this simple, visual aid what has happened.
Professor,
Yes.
one sec. Can you turn off one of the lights so you can't really see?
That's better. So you combine with the oxygen, lose a hydrogen, lose an electron, or electron. Can be more than one?
Yes.
Okay. It can be one or no?
Yes.
Okay.
This table's in the slide, right?
This table?
Yeah.
I don't. I think I got this from a different book.
Hold on.
Okay? Now, reduction. If you lose oxygen, if you combine with hydrogen, if you gain electrons, or if you decrease your oxidation number, this is you can classify these characteristics as reduction. Okay? You see it? You see it? You see it?
Hold on,
Okay,
is
the
this?
number.
She shut down there. I ain't telling me to turn off like.
No, it's still not working. It's not there.
I get out of my house. Oh Lord, okay. Alright, so here's some examples, okay? Oxidation. Here, what's happening to iron here?
It's never reduced.
Oxidation, reduction. You sticking to that alone. What is happening to iron? It combines with oxygen. It's gaining oxygen to make your iron 3 oxide. So therefore, this is an example of oxidation. One of the examples of oxidation is to gain an oxygen, right? Hydrogen gas, oxygen gas. You have water. You have just gained an oxygen.
Doesn't it matter how you look at it?
Well,
How you gain?
Couldn't you look at that and say,
I mean,
alright, oxygen gained hydrogen?
now,
How come you can't say that?
well, in terms of oxidation specifically, you have one species gaining oxygen. But remember, with reduction, you would have to lose what?
Hydrogen.
Hydrogen.
This says combined with hydrogen.
What?
It says combined with hydrogen. You didn't put combined with hydrogen for the reduction?
But is this under reduction?
No, like
Is this under
if it didn't
reduction?
say that though.
But is this under reduction? Thank you. Right? Reduction examples. Right? My copper 2 oxide. What is happening to my copper 2 oxide? It's losing an oxygen. Okay?
So
You
reduction is when you lose oxygen, and oxidation
Wait, what? Tell me again.
is when you lose an oxygen.
What is
reduction?
when? Reduction is
When you lose an oxygen.
you can lose when you lose an oxygen, you've undergone reduction.
Okay, and when you gain an oxygen, it's oxidation.
Yes.
Okay.
Right? That's one of 4 or 5 ways to identify oxidation and reduction. Right? Lastly, when your iron 3 oxide, what is happening to it? Loses an oxygen with the watermelon in your mouth. Okay? So therefore you have undergone, Imam, what's the matter?
So the oxygen, so carbon monoxide, right? So it's
Carbon.
oxidation reaction. Or,
This one right here?
yes, both oxidation and reduction, or just reduction.
What do you mean?
Like it,
The carbon? Are you talking about what the carbon is doing?
yeah,
What is the carbon doing?
it's getting the oxygen, right?
So what does that mean?
It's the oxidation.
Going to oxidation. As I told you, oxidation, reduction go hand in hand. If one occurs, the other must occur. Your iron 3 oxide is doing what? What is happening to it?
It's losing the oxygen. So it's just
Reduction. Therefore, your carbon is doing what?
Oh, so it
Reaction.
happens, so both have to occur.
It will always occur at the same time.
Okay, so can I please ask you, can we take it back to the hydrogen gas and the oxygen gas? Look, she's nodding. So hydrogen, hold on, time on now. Hydrogen, right, gains an oxygen. So it's being oxidized. Correct, that's what you said. But oxygen is also gaining hydrogen, so it's being reduced. That's what I said! You heard me say it! And she looked at me like I was crazy.
Because you were like, okay, you read it this way, like.
And if
exam, like I can use that either way, any example for like oxidation or reduction in this photo plus inhibitor.
Right. However, you will not necessarily know by the equation itself if it's a redox reaction.
Like
Because you must be able to tell the difference in the oxidation numbers. The oxidation numbers must change in order for you to have a redox reaction.
what is the oxidation number? That's what I don't understand.
Nice segue. Okay? Oxidation numbers or oxidation states. Okay? Judgment, I smell it over there. Okay? Oxidation numbers are positive or negative numbers assigned to your element in a chemical formula according to my specific 7 rules that you must memorize. Okay? Now, I'm going to preface my rules. My oxidation numbers sometimes will resemble your charges. Sometimes.
Why is all of this exceptional in science class?
Because there are exceptions in life.
Oh God.
Okay? So, what is the maximum charge you can have?
3, 8.
6, 7.
Nah, wow.
Right?
8.
How is it?
Wait, no, I said 3 at
Maximum is
first.
4,
When you
like
looked at
4.
me. So I
Well,
just had to
what 3?
plus 3 minus 3.
Plus 3 minus 3. I don't know where you get 6 from. You kind of left field with that one. Right? Plus or minus 3. That is the maximum charge you can have. Your oxidation numbers can be plus or minus 6. Yeah, I just shocked you right there. I know. I said charge. There you go. There's a difference. Okay? The only way that you will be able to figure it out is by my 7 rules. Yes.
So it's plus or minus 6?
No. We don't know exactly what it's going to be. Sometimes we won't know in the reaction side, but sometimes we won't know in the product side.
I'm just trying to say, like, the range, like, this, the charges is...
It can go up to 6. Plus or minus 6, it could be that. Okay? But remember, this is not the charge. Sometimes it will be the charge. No, it's not. Okay? Alright. Rule number 1. Any uncombined element has an oxidation number of 0. What does that mean?
Elements in the elemental form.
Element in the elemental state. Iron, chlorine gas, hydrogen gas, oxygen gas, nitrogen gas, fluorine gas. All these things will have an oxidation number of 0. If you see them by themselves, uncombined, by themselves, the oxidation number will be 0. You get that?
So you're like hydrogen, you're saying it's
Hydrogen
Yes.
what?
gas. No, that's not by itself.
Yes, how is it not by itself?
Oh, okay. I thought just H is by itself.
But okay, you have hydrogen atom
Yeah,
and you have the hydrogen molecule. Which one are you talking about?
I'm talking about
And you have the hydrogen ion. You have 3
not
species.
the ion.
Not the ion.
The one on the periodic table is the
That's the element.
Okay, so the element.
But the element is actually found as H2.
Okay. So then that's just an example of 0.
Yes.
Gotcha. And so then would you say that oxygen is O2?
Yes.
Is it?
But remember, it's oxygen.
Because it's what it's in the world. Like what's the?
That's
what is it
in
the
nature?
environment? Yeah.
Oxygen is never found
as
as
an element. So
atom.
Gotcha.
It will be oxygen gas. You cannot breathe oxygen. You breathe oxygen gas.
Gotcha.
There's a difference. Okay,
So should all the gases be considered a gas?
What? What?
Like all the gases in the periodic table, are you just saying?
But wait, where's all the gases in the periodic table though? But not all the halogens are gases.
7 gases.
Yeah, it doesn't know what
But-
gas is.
Oh, you're talking about that thing that goes like that?
I'm just talking about
No.
the difference in the noble gas.
Well, that that one. But you have nitrogen gas.
Yeah.
That's a gas.
Yep.
You have oxygen gas. That's a gas.
Gotcha.
You have fluorine gas. That's a gas.
So
You
anything
have bromine.
Yes.
Bromine is actually a liquid. You have iodine.
that's not a gas.
Iodine can turn into a gas, but it's a solid.
Yeah.
Okay? So we call them, well, we didn't call them gases. What did we call them?
Yeah, so-
What did we call them?
Halogen.
No,
Ideal.
no.
No, there's a.
Die. No.
Oh.
Diatomic molecule.
Thank you!
Oh, that's wrong.
Like,
Beyond the R.
okay? Diatomic molecules. Okay? That is what we
That's
call
what they
these
are in
things.
nature, that's it.
Yes, that's what they are in nature.
That, gotcha.
Okay? Rule number 2. If you have a simple ion, your simple ion, either by itself or in a compound, the oxidation state is equal to its charge. So for example, remember, this is in a molecule or a compound. If you have magnesium, the charge of magnesium is 2+, so therefore the oxidation number is +2.
Oh, you're saying if it actually shows like the charge of the ion.
No, in a molecule.
Oh, in that molecule.
Okay? In a molecule, you can either see it by itself, just the simple ion by itself, or if you see it in a molecule, you can do the reverse crisscross, get your ions, and that will be the oxidation number. Alright? Here you have oxygen. Oxygen ion has a charge of 2-. Therefore, the oxidation number is -2. Do we get this? Okay. Rule number 3. Again, in a compound, if you have elements of group 1A or group 2A, their oxidation numbers will be equal to their charge. Everybody in group 1A will have a +1 oxidation number. Everybody in group 2A will have a oxidation number of +2 in a compound. Okay? For example, here you have sodium sulfide. Sodium is in group 1A, so therefore the oxidation number is +1. Calcium nitrate. Calcium nitrate is in group 2A, so the oxidation number is +2, yes.
And is that depending on what it's combined with, or
No.
is that's all the time?
All the time.
Group.
1 and 2.
1A, 2A,
That's only for those two.
yes. So Miss, should be the time?
It's 10:40.
You got some. Okay? Rule 4. Hydrogen. Remember, this is a hydrogen atom, not hydrogen gas. Hydrogen atom in a molecule will always be +1. No ifs, ands, or buts. Will always be +1. In a molecule, you see hydrogen, the oxidation number is +1. So here you have hydrobromic acid, hydrogen +1. Sulfuric acid, hydrogen +1. Now,
Should I wait?
No.
So you can, okay, so say for instance, this example for sulfuric acid.
Good job.
This is not hydrogen gas because it's balancing to meet
Right.
the polyatomic ion.
Right.
So if it were another case where like H2O, is that an example
Yes.
of a hydrogen gas?
No.
That's just an example of this again.
Yes.
Okay.
So again, what Tatiana is saying is that do not try to separate this molecule and say that this H2 is hydrogen gas, so therefore you will make that an uncombined element and therefore make the oxidation number 0. Don't do that. This hydrogen in a compound is an atom. So therefore the oxidation number will be +1. Okay? Rule number 5, oxygen in a compound will always be -2, except if you have a peroxide. If you have a peroxide, it's going to be -1. For example, here you have, what did you say?
H2O2.
H2O, yes. Here you have magnesium oxide. Magnesium oxide, your oxygen is in a compound. So therefore, the oxygen has an oxidation number of -2. Bromic acid. Have oxygen here. You have, the oxygen will have a -2 charge. Now how many oxygens do you have?
3,
So overall, how many?
6, 6.
You have a total of -6 charges that's coming from your oxygen. But each oxygen, the oxygen atom itself, is only -2.
Oh, so
I saw her hand first.
I have 2 questions.
Yes.
The acid, without the H, would that be bromine?
Bromate.
Okay, another question. What do you mean by peroxides? Like,
Hydrogen peroxide.
so you said peroxide.
Yeah. I
So
was
there's
thinking the
more,
same thing.
there's more than one type of peroxide. You know, it's not just hydrogen peroxide.
I didn't know.
Well, no, you know.
Now I know. So how do you have the different forms like the H?
So this could be, if anytime you have like this O2 at the back, and how the structure is, the structure would look like this. This hydrogens can be anything.
You mean that's like the number of the hydrogens change?
It's how the oxygens are bound together.
So the oxygen is always combined like
Yes,
linear.
Yes. yes.
I know it's not the same thing. You know what I'm saying?
I know what you're saying.
So the bromic acid. So what is the like oxidation number for that? -6.
Yes. We're gonna get that with rule number 6. Don't you worry about that. Monique, you got a question?
no, my body just growled. I'm sorry.
Okay. Rule number 6. In a neutral compound, all of your oxidation numbers need to add up to 0. Okay? For example, let us take, let's take calcium carbonate, okay? CaCO3. By rule 6, what do we need to do to this?
Make it 0.
Make it 0?
Must be 0.
The sun.
The sum, so it must equal to 0. Right? So the first thing you do after you set it to equal to 0, you now need to count out how many of each atom you have present. So what's the first one?
Calcium.
How many?
+1.
So you have 1 calcium plus
1 carbon.
1 carbon
1
plus
3
3 oxygen equal to 0. Now, by rule 3, by rule 3, what does calcium equal to? Plus 2. So you have 1 times plus 2.
Plus 4. Legacy.
Plus 4.
Plus 4.
No, you can't do that because we don't have a rule for carbon. Rule 6 allows you to find carbon, but from the jump, based on our rules, we don't have anything for carbon, so we still have our carbon there. By rule 5, what do we know about oxygen? So we have 3 times -2, all equal to 0.
Because oxygen by itself, it takes its number, its charge.
No. Oxygen is always -2. That's a rule. Right? So now we have 2 plus C. What does this equal to?
-6.
Very good. -6 equals 0. Combine both numbers.
So it's -4.
We have C
Equal to 4.
minus 4 equals 0. Solve for C. How do we do that?
Equal to plus 4.
How do we do it though?
Put the
Add
4
4
there.
on both sides.
Add 4 on both sides.
Plus 4.
C is therefore equal to plus 4. And you must,
Show them.
and I said must, give me my sign.
Okay.
Even if it's a plus, and you think, well, I can leave it out, if it's not there, it's a plus sign. No, you must write the plus. Okay? This is the type of math you do for oxidation numbers.
That's not bad.
No, it's not bad. It's not bad at all. Okay? So here we have, okay, so let's do that one. Oh my God. What's the name of this? Thank you. Okay. What do we do?
Separate, you see how much it is of each one? No?
So what do we do? Tell me.
Mg.
How many?
1. Sulfur 1. You don't separate those?
I did.
No, the sulfur.
So
1. Oh, okay. Because you look back. I was like 4 oxygen.
Wait, we never worked with white.
Equal 0.
we ain't there yet.
So then why are you using that?
Because this is a neutral compound. Now, by rule 3, what do we know about magnesium?
Plus 2.
Plus 2.
It's rule 2.
Oh, rule 2. Oh, my fault. Do we have a rule for sulfur?
Yeah, rule 8.
Rule 8. How you get to rule 8? I said finish in rule 6.
No.
We don't. So sulfur stays as is. What's my rule for oxygen?
That is 2 times 4.
So you have 2 plus S plus, no.
-8.
So this is -8 equals 0. Combine both numbers. Sulfur -6 equals 0.
Plus 6.
Plus 6 on both sides.
Plus 6.
Sulfur is equal to plus 6. Yes.
Like for the get the whole points, we have to do all the process.
Yes, ma'am.
Like we can exceed the
Yes,
number.
My fault. I got Monique's face in my head. Wow. So because then you have just since day 1.
Do nothing.
Did. Okay? So this is what we got. Okay? So again, we see the charge on sulfur is what? What's the charge on sulfur?
Plus 6.
No. Listen to my question. What is the charge on sulfur? -2. What is the oxidation state on sulfur in magnesium sulfate?
Plus 6.
Plus 6. So understand the difference
The
in this
charge
question.
and the oxidation is different.
Exactly. Okay? Don't get them mixed up. Rule number 7. If you have a polyatomic ion or you have a compound that has a charge, the compound must equal the sum of the oxidation numbers of this compound must equal to the charge.
So the polyatomic ion?
Yes. So let's take something that we know. Right? What's this?
Phosphate.
Phosphate. Based on rule 7, what do we do?
It's the charge of
What about the charge?
It's gotta be the oxidation. It has to be
No.
negative.
It has
The
to
sum.
equal the sum
Sorry.
of the oxidation numbers must equal to this charge. So what do we write?
So P plus O4.
No.
4
O.
oxygens equals -3.
Good job.
Okay.
Do we have a rule for?
No.
We do not. So we bring that down. -2 equals -3. Phosphorus, -8 equals -3.
Combine those.
Combine by plus
We can't combine these. What do we need to do?
plus 8.
+8 on both sides.
Did you?
So it's like
You can't combine. Combine is on the same side.
okay, that's what I said it wrong, but that's what I meant.
So it's 5.
Good job.
Why does it send the
Did you
minus-
multiply?
Huh? I did that wrong? What did I do wrong?
Did you multiply the oxygen by 4?
Yes.
So -2 times 4?
Yes.
Negative.
Yes. Now the example, you solve for the one that you do not have a rule for. Okay? Do you want to take a break?
Yeah, sure.